All right, guys, we're starting chapter 2 section of the review. This is question number 15. 15 says, write the equation y equals 2x squared plus 4x minus 1 in vertex form. That means we're, again, completing the square. Let's work on it where we got lots of space down here. This is 15, part A. So I've got 2x squared plus 4x minus 1. Okay, so completing the square again, typical thing, but this time I got a 2 in the front. So let me tell you guys my preferred way of dealing with that. What I like to do is just factor that 2 out. And then see what I have left for x squared plus 2x this time, right? And then leave myself some space here. Now, I'm going to leave this minus 1 part, this constant part on the outside. And then the reason for that is because that's not going to be helpful for me really in completing my square here, right? And then so this 2 that I have factored out, it only applies to this portion here. And this minus 1, I'm just leaving as a separate thing. And for that reason, I'm going to just give it a whole different color. So let's keep it as original, minus 1, black. Okay, now let's do the red part. So red part, I've got x squared plus 2x in the middle, and I'm going to just go ahead and complete the square inside here. Complete the square. What do I need to add there? I need to add half of this side, this thing squared, right? Let's do purple. No, this is a blue. Blue looks better with red. So half of 2 squared is 1, right? So 1. Okay, right now, what I just did right now is I changed the equation though, right? I added something. So now this is no longer the same as where I started. So how do I compensate for that? Well, I should subtract it. And your initial thought might be, okay, if I added 1, I should subtract 1, right? That's a good idea, except you're not right. You're wrong because this plus 1 is going to get multiplied by that 2. So when it gets multiplied by the 2, it ends up being a plus 2, right? So to compensate over here, I got to subtract 2. Okay, so now everything's in up and up. This plus 1 is really a plus 2, is compensated for by subtracting 2. So really what I did is I just added 0 in a clever way. I haven't really changed anything. Everything is still as it originally was. Now I can continue. Go ahead, complete the square. This portion right here, my whole purpose of adding this 1 was that so this guy would become a perfect square, which now it is. This is x plus 1 squared. Yeah. And over here I got minus 3. So now it's beautiful, beautiful vertex form. And what is that vertex? That's the next question. So we've got vertex form. That's part A done. Part B, what is that vertex? Comes from right there and right there, right? The plus 1 means the x-coordinate is negative 1. And the minus 3 means it's minus 3. Remember, it's always opposite for this inside part, right? It's x minus h plus k. The vertex form. Okay, so negative 1 comma negative 3 is the vertex. Now to sketch the thing and then determine the domain range. Sketching is easy here because this is really just x squared but translated, transformed. By 1 to the left, 3 down, right? So that's my starting spot right there. Okay, now this is a positive 2, so it should be opening upwards. And because it's 2, instead of going up to the right 1 and up 1, I'm going to the right 1 and up 2. Because normally if you think about the original x squared graph, it looks like this, right? You go right 1 and 1 squared is 1, so you end up going right 1, up 1. But because this is stretched by 2, it should be up 1, right 1, up 2, and left 1, up 2. And normally with the squared, you go to the right 2 and you go up by 4. But this case, I'm going to go right 2 up by 8. If you want to have a second point. 1, 2, 3, 4, 5, 6, 7, 8. So should be to the 2 to the right, up by 8 this time. So you got this really narrow looking parabola, yeah? And it's kind of should be something like this. Symmetric. So that's the sketch. That was part C. And then part D, domain and range. It's pretty obvious just looking at the thing, right? The domain, we'll say DOM for short, is everything. Because it goes to the left and right forever. And then the range. Don't be alarmed by the fact that it seems to go to the left and right slower than normal. It doesn't matter. You get there eventually. The range is, sorry, hard bracket first. The lowest point, -3, and then on upwards forever. That was 15. Let's go on to 16. Okay, it says for the following polynomial, describe the end behavior, find the zeros, determine where the thing crosses or touches at each zero, and then sketch. Well, this is nice because it's already factored for us. So really, this is a simple question, easy question. It's one that most people had right on the exam. End behavior first. This is 16, part A. So as x goes to -infinity, and then as x goes to positive infinity, those are the two end behaviors, right? As x goes to -infinity, first thing I want to know is, okay, let's just extract the key elements here. I got -x squared, I've got an x cubed, and an x squared. So I've got -x squared, x cubed. These are just the leading terms that are going to pop out, right? That's going to be negative x to the 1, 2, 3, 4, 5, 6, 7. Negative x to the 7th. Okay, so x to the 7th, as x goes to -infinity, that's going to be -infinity, right? It's going to head towards -infinity. But then I got this minus sign, so that means f of x goes towards positive infinity. Okay, what about as x goes to positive infinity? As x goes to positive infinity, x to the 7th goes towards infinity, but then I got this negative sign, so f of x goes towards -infinity overall. All right, so that's end behavior described. We're going to match that up once we hit the sketch of the graph. Find the zeros, determine where they cross or not. So this is easy because it's already factored for us. So the zeros, x equal to 0, x equal to 1, x equal to 4. Right? Those are the three things that will make it 0. And to determine where the crosses or touches, you just check the multiplicities. If it's even, it's going to just touch. If it's odd, it's going to cross. So looking at it, the 0 case is even. The 4 case is also even. So those are both touches. And at 1, it's going to just cross. Okay, so that's that. Okay, now to sketch. Here's x, here's y. Okay, so let's start by plotting our zeros. So we got one at 0, one at 1, and 2, 1, 2, 3, 4. 1, 4, yeah? To the left, it should be positive infinity. So I should be up top on the left. When it hits 0, it should touch. It's going to cross at 1. And it's going to go back up. Oh, I'm sorry. Touch. It just touches the first one, right? It crosses the second one. Third one, it only touches. So it should go back down like this. Okay, does that match our end behavior? Infinity on the left, -infinity on the right. Yep. So there it is. There's your sketch. Okay, moving on. Let's try to do 17, 18 in this video. 17. Complete the following task for the polynomial. Okay, got this thing. Determine the number of positive and negative zeros. Okay. So this is 17, yeah? Then we're going to do the psh, and then for the positive sign changes. Starts from positive, changes to negative once, back to positive, that's 2. So there's 2, so 2 or 0, positive zeros. Okay, for the negative sign changes, I gotta check the f of negative x. That's gonna be negative x. Remember, if anytime you have odd powered switches, right? Changes sign from the original polynomial. Otherwise, it stays the same. So x squared, negative x squared stays negative x squared. Negative 4x becomes positive 4x because that's an odd. And then positive 4 stays positive 4. Oh, I'm sorry, guys. I just realized there's a typo here. This should not say equal to 0 over here. That's not necessary. Okay. Where were we? So this is negative, negative, changes to positive. That's one sign change. So 1, negative 0. So that's nice. I know there's got to be a negative 0 and exactly 1, in fact. So I determined the possible number of positive and negative zeros. That's part A. Part B says determine all possible rational zeros. Okay. So for that, I'm looking at my original polynomial. Here, the last number is 4. First number is 1. Coefficient, yeah. So then rational zeros, or I should say possible rational zeros. The top should divide 4, bottom should divide 1. So that makes it all whole numbers, plus or minus 1, plus or minus 2, plus or minus 4. Easy. Okay, now I use synthetic division and the quadratic function equation to find all zeros. Let's look for the negative one, because I know that I'm guaranteed to have a negative one, right? So let's check negative 1. I've got 1, negative 4, 4 as my coefficients. Bring the 1 down, that's 1. 1 times negative 1 is negative 1. Negative 1 plus negative 1 is negative 2. Times negative 1 is positive 2. Plus negative 4 is negative 2 times negative 1 is positive 2. That is 6. So that's no good. Let's try negative 2 next. I feel like I might have made an error in that synthetic division because I was kind of rushing, but don't rush when you do yours. Okay, 1 comes down. 1 times negative 2 is negative 2, plus negative 1 is negative 3, times negative 2 is positive 6, plus 4 is going to be positive 2, sorry. Times negative 2 is negative 4, plus 4 is 0, so there you go, that's 1. Negative 2 was one of our roots, and the remaining polynomial is x squared minus 3x plus 2. I could continue with synthetic division, or I could just use the quadratic equation at this point. I find synthetic division easier, so I'm going to try that. Because in this case anyway, because I only have 3 options, plus or minus, right? I already found the one negative one. So I know if the other ones are rational, they've got to be positive 1, 2, or 4. So let's just check those. That's pretty fast. Let's check 1. With this remaining, this is the new, what do you call, polynomial I'm using, yeah? 1 comes down. 1 times 1 is 1. Plus negative 3 is negative 2. Negative 2 times negative 1. Times 1 is negative 2, I mean. Plus 2 is 0. So I found another one. And what's the remaining one? This is x minus 2. Oh, so that's actually basically done, right? I don't even have to check. I already know the answer to that is 2. So look what I found. Negative 2 was one of the roots. Positive 1 is another root. And then the last one is going to be from here. It's going to be 2. So 2 is my last root. So I found my 3 zeros. Let me package them in a nice package. I'll say zeros are negative 2, positive 1, and positive 2 in a little box. And then now sketch the graph. Okay. So let me sketch it. I'm going to just do it in this little pocket right here. I'm going to start by plotting my zeros. Negative 2 was one of them. Positive 1 was another. And then positive 2 was another. Yeah. Each of them has multiplicity of 1. So I'm going to cross all 3 cases. And looking at my original function, this is my original function, right? End behavior is going to be negative to the left, positive to the right. Because x cubed is the dominant term. And x cubed is negative when x is negative. So it's going to be negative, cross through, cross through, cross through, and a positive. There's the graph. All right. Somehow I ended up zoomed out. Sorry, guys. Here's just everything again, in case you missed anything. And one more question before we take a little break. And I'm in need of a break actually after this. So I'm gonna do this question and then wrap up this video. I feel like this video might have been going long again, but I haven't been keeping close track, as you have gathered. First video was 30 minutes and then like a 15-minute one, and then I don't know what the third one was. Wait, is this the third one? No, this is the fourth one, yeah. Okay, 18 says use synthetic division and the remainder theorem to find the value of the function. Okay, easy. Find the value of the function when x is -2 and x is +1. So that's easy. The remainder theorem says the remainder is the value. So when I run my synthetic division, the remainder is exactly the value of the function at that point. So here, let's run our synthetic division. 2, 1, -15, -2, those are coefficients. 2 comes down. 2 times -2 is -4. Plus 1 is -3 times -2 is +6. Plus -15 is -9. Times -2 is +18. Plus -2 is +16. Which means that f of -2 is +16. Okay, and then we're going to do the same thing for +1. 2, 1, -15, -2. 2 comes down. 2 times 1 is 2. Plus 1 is 3. Times 1 is 3. Minus 15 is -12. Times 1 is -12. Plus -2 is -14. So that means f of +1 is -14. And that is part A already. Yeah. Okay, now letter B. Does a real 0 exist on in the interval -2, 1? Why or why not? I just checked -2. I found that it's negative. Oh, let me right here. F of -2 is 16, positive. F of 1 is -14, negative. So there must be a 0 by the intermediate value theorem. So by the IVT, which stands for intermediate value theorem, there exists a 0 in the interval -2, 1. And this is a question, there was a question on the exam about the IVT, and almost everybody got that one correct. So good job, guys. Okay, that's it for this video.